Welcome to Module 14, Supporting Windows. This module covers essential skills for troubleshooting Windows networking, remote access, performance tools, and common operating system problems, all of which are critical for your A+2201202 certification. By the end of this module, you will be prepared to handle OS installations and upgrades, manage application configurations, and perform effective troubleshooting on Windows systems. Lesson 14.1 focuses on troubleshooting Windows networking. This material directly supports A+2201202, Objective 1.5, which tasks you with selecting and using the correct Microsoft command line tools in various scenarios. In this lesson, we will explore the command line tools needed to view IP configurations, test connectivity to local devices and remote sources, retrieve DNS records, and monitor active network connections. The primary command for viewing your network interface configuration is ipconfig/all. We will also look at useful switches like /release and /renew for DHCP management and /flush DNS to clear your cache. To test local connectivity to a device like a network printer, we use the "ping" command. If successful, you will receive reply messages. If it fails, you may see a request timed out error. Adding the T-switch allows for continuous testing. When you need to test connectivity to a remote source and identify where delays or packet loss occur, use "tracert." An alternative is "pathping," which provides more detailed hop-by-hop statistics. This video shows an example of tracert in action against a domain. You can see each hop in the network path, the time taken, and the specific IP address associated with that stage of the route. Here, we see the output of "pathping." Unlike tracert, this tool conducts a prolonged test, allowing it to calculate packet loss statistics for each node along the path. For troubleshooting name resolution issues, the nslookup command is your go-to tool. It allows you to query DNS servers for various records, such as A, quadruple A, or mail exchange, or MX records. The netstack command is essential for viewing active TCP and UDP connections on your system. Using switches like A, B, or N helps you identify listening ports, specific processes, and numeric addresses. Our troubleshooting approach for Windows networking covers 5 key areas: IP configuration, local connectivity, remote connectivity, name resolution, and monitoring network ports. When diagnosing IP configuration, watch for no internet access or limited connectivity. Always check for API/IPA addresses, which usually start with 169.254, as this indicates a failure to obtain an address from a DHCP server. To troubleshoot local connectivity, follow a logical path. Ping the loopback, then your own IP, then the default gateway, and finally, a remote host. Unsuccessful messages provide clues to where the connection is failing. Finally, we conclude this lesson with a networking simulation. You will practice using the command line tools we have covered to identify root causes and resolve network issues, ensuring you document every step of the process. Let's move to remote network connectivity. The tracert command traces the path a packet takes to its target, while pathping serves as an alternative that pings each hop and determines the round-trip time. When troubleshooting name resolution, consider the security layer, name resolution layer, or application layer. The nslookup command is essential for testing if DNS servers can correctly resolve host names to IP addresses. The netstack command is powerful for investigating open ports and active connections. By using specific switches, you can identify which services are running and detect potential unauthorized activity on your local system. Next, we explore Lesson 14.2, Remote Access Technologies. This lesson maps directly to the A+2201202 Certification Exam Objective 4.9, which focuses on utilizing remote access technologies in various scenarios. In this lesson, we will answer key questions regarding remote administration tools, security implications, the differences between remote assistance and remote desktop, file transfer methods, and how VPNs secure connections. The native remote administration tool in Windows is Remote Desktop Connection, or MSTSC.exe. It uses the Remote Desktop Protocol, or RDP, over port 3389 to provide a full graphical desktop experience. Using remote administration tools requires caution. Risks include unauthorized access and interception. However, you can protect against these by using network-level authentication, strong passwords, MFA, and keeping your systems fully patched. Understand the difference between remote desktop and remote assistance. While remote desktop takes full control and logs the other user out, remote assistance allows both parties to see and control the desktop, perfect for training. When you need to transfer files, options range from built-in remote desktop capabilities and Windows Nearby Sharing to dedicated protocols like FTP or third-party applications like OneDrive and TeamViewer. Virtual private networks, or VPNs, secure network connections by creating an encrypted tunnel between the client and server. This prevents data sniffing and ensures both confidentiality and integrity over the public internet. This lesson covers various remote access technologies, including RDP settings, Microsoft Remote Assistance, Secure Shell, desktop management tools, and the simple protocol for independent computing environments, or SPICE. When working with remote desktop, prioritize security. Limit access to trusted users, ensure encryption is enabled, and always secure your connection with firewalls, VPNs, and strong multi-factor authentication. Virtual network computing, or VNC, is a cross-platform alternative to RDP. While versatile, it is generally less secure than RDP, unless you specifically add an extra layer of encryption, such as an SSH tunnel. To configure RDP, use the remote desktop settings in Windows. Remember to use network-level authentication to prevent unauthorized access before the login screen. Regularly monitor your logs to stay ahead of potential threats. Microsoft Remote Assistance simplifies end-user support. By generating a passcode, a user can invite a technician to assist them, facilitating a collaborative troubleshooting session without taking full control of the remote computer. Next is WinRM, or Windows Remote Management. It is a command line service built into modern Windows, allowing administrators to remotely execute scripts, run commands, and query system information on other Windows devices. WinRM uses SOAP messages and communicates over HTTP port 5985, or HTTPS port 5986. It integrates with PowerShell remoting through commands like enter PS session. Note that for exam purposes, if a question specifies remote command line management via HTTP or HTTPS, the answer is WinRM. Secure Shell, or SSH, is a protocol for secure remote access to a command line interpreter. It runs on TCP port 22 and uses encryption keys to prevent snooping. Unlike Telnet, which is unencrypted, SSH is the standard for secure remote CLI access. We also use RMM and MDM tools for desktop management. RMM stands for Remote Monitoring and Management, used for servers and desktops, while MDM, or Mobile Device Management, is specifically for smartphones and tablets to enforce security policies and remote wipe capabilities. This dashboard example shows how RMM tools provide a centralized view, enabling IT teams to monitor device status, manage patches, and track performance across an entire network of endpoints. The Simple Protocol for Independent Computing Environments, or SPICE, is a remote display protocol designed for virtual machines. It allows users to interact with VMs over the network, supporting features like USB and audio redirection. On the exam, remember SPICE is focused on virtual infrastructure. Finally, various tools assist in remote collaboration and file sharing. From screen sharing apps like Teams to file transfer tools like AirDrop and Nearby Sharing, these utilities help technicians resolve problems or move data efficiently between devices. Welcome to this video on performance and troubleshooting tools. This lesson covers CompTIA A Plus Exam Objective 1.4, which focuses on utilizing various Microsoft Windows operating system features and tools to diagnose and resolve performance issues. In this video, we will explore several key topics: the capabilities of the System Information Tool, default Windows logs, the performance monitors found in Task Manager, and the key differences between those monitors and the dedicated Performance Monitor tool. The System Information Tool, accessed via msinfo32.exe, provides a comprehensive report of your computer. It covers hardware resources, installed components, the software environment, and network settings. It is the go-to tool if you need a quick complete system inventory or need to identify driver or BIOS versions. This view shows the interface of the System Information Tool. Note the categorized tree structure on the left, which allows you to efficiently navigate through different aspects of your hardware and software configuration. Event Viewer is your primary tool for analyzing system events. Windows maintains several default logs, including the system log for hardware and driver events, the application log for software errors, the security log for audit and login data, and the setup log for installation events. Here is the Event Viewer interface. You can see the Windows logs in the left pane, which categorize events to help you pinpoint the source of a system crash, login failure, or configuration warning. Task Manager's Performance tab provides a real-time window into your system's health. You can monitor CPU utilization, memory usage, disk activity, network bandwidth, and GPU performance. If you need to manage programs that launch at boot, remember to check the Startup tab. This image highlights the Performance tab in Task Manager. These live graphs offer an immediate snapshot of resource usage, making it an excellent first stop when troubleshooting a system that feels sluggish. While Task Manager is perfect for quick, real-time troubleshooting, the Performance Monitor tool, or perfmon.exe, is designed for advanced, long-term analysis. It allows you to create custom counters, alerts, and detailed logs, which are essential for capacity planning and historical trend analysis. This comparison illustrates the different purposes of these tools. Task Manager gives you a view of the now, whereas Performance Monitor allows you to track and log performance data over days or weeks. In this Performance Monitor view, you can see how specific counters are configured. This is where you would define the metrics to track for your long-term performance reports. To summarize, this lesson has guided you through essential Windows diagnostic tools, including System Information, Event Viewer, Task Manager, and Performance Monitor, providing the foundation for effective system administration. We have covered how to utilize user monitoring, manage startup processes, track resources, and leverage performance counters to keep a Windows environment running optimally. When using the System Information tool, remember that it is organized by hardware resources, components, software environment, and network status, making it highly effective for asset management and verifying system compatibility. Finally, when troubleshooting hardware or driver issues, always check the "problem devices" category under Components in the System Information tool. It is often the quickest way to identify why a component is failing to function correctly. Moving on to Event Viewer, remember that you can launch it directly by typing eventvwr.msc in the Run dialog. This tool is your primary window into the health of your Windows system by providing access to detailed logs. Event Viewer tracks several default logs. The system log records OS events like hardware failures, while the application log keeps track of software-specific errors and status information. Additionally, the security log is essential for tracking login attempts and audit events, and the setup log is used to monitor activities related to Windows setup and system updates. It is important to understand the different event severity levels. Critical events indicate an immediate failure, like a crash, while errors represent significant problems that occur while the OS is still running. Warnings alert you to potential future issues, while information events simply log normal operations. You will also see audit success or failure entries, which record specific security-related access attempts. When a user reports an application crash, checking the application log in Event Viewer should be your first troubleshooting step to find the specific error details. Now, let's discuss Task Manager. This tool allows you to monitor critical system resources, including CPU, memory, disk, and network usage. It is invaluable for identifying hung or resource-heavy applications. You can open Task Manager using the shortcut Ctrl+Shift+ESC by right-clicking the taskbar or by using the search function in the Start menu. Within the Processes tab, you can view all active apps and background processes. Expanding a process allows you to see granular detail on its current impact on your system resources. If an application is unresponsive, you can right-click the process and select End Task to force it to close. You can also right-click a process to adjust its priority level if needed. Be cautious when managing processes. Terminating a critical system process can lead to system instability, causing your OS to crash or behave unexpectedly. The Performance tab provides real-time graphs for your hardware. This includes CPU details like core counts, memory usage statistics, disk activity, network throughput, and even GPU performance data. By monitoring these performance metrics, you can identify real-time hardware bottlenecks. For example, if CPU usage is consistently near 100%, you know your system is working at capacity. The App History tab helps you track the resource consumption of Windows Store apps over time, which is especially useful for identifying background processes that are draining your battery or data. Now, we will examine the Startup tab in Task Manager. This section lists every program configured to launch automatically when you log into Windows. It displays the publisher, enabled status, and the startup impact of each application. If your computer is booting slowly or lagging immediately after login, you can use this tab to disable unnecessary startup apps. This is also a key area to check if you are troubleshooting suspicious or unwanted programs. Next is the Services console, accessed via services.msc. This tool provides advanced management for background services. Here, you can start, stop, or restart services, change their startup type, and configure recovery options in case of a failure. While disabling unnecessary services can improve system performance, be very cautious. Disabling essential services, such as the Windows Update or Network List services, can cause significant system instability. For deeper analysis, the Resource Monitor, or resmon.exe, provides a real-time, granular view of system activity. It is particularly effective for identifying resource bottlenecks or tracking disk-heavy applications that Task Manager might not capture in sufficient detail. The Performance Monitor, or perfmon.msc, is our tool for long-term tracking. It uses performance counters, organized into objects like memory or processor, to log data over time, which is invaluable for capacity planning and trend analysis. Finally, the System Configuration Utility, or msconfig, helps control startup modes, including normal, diagnostic, or selective startup. Its Boot tab is essential for troubleshooting issues that prevent Windows from loading normally, while the Tools tab offers quick access to your primary administrative utilities. Welcome to Lesson 14.4 on Troubleshooting Windows OS Problems. This video aligns with A+ Certification Exam Objective 3.1, which focuses on your ability to troubleshoot common Windows operating system issues. In this video, we will cover the normal boot process for BIOS and UEFI configurations, essential tools for resolving boot issues, the options available in System Restore mode, and how to interpret information found on a blue screen of death. Let's begin with the boot process. In a legacy BIOS setup, the system performs a POEST, loads the master boot record, and passes control to the bootloader. Modern UEFI systems are faster, support larger drives, and use the EFI system partition to load the OS loader directly, while also offering secure boot for added protection. When troubleshooting boot issues, you have several powerful tools at your disposal. These include Startup Repair for automatic fixes, the bootrec.exe and bcdedit command line tools, Safe Mode for isolating software conflicts, and the System File Checker or SFC, which can scan for and restore missing or corrupted system files. When using System Restore, you can choose a specific restore point, scan for programs that will be affected by a rollback, select different restore points, confirm which drives to include, or undo your last restore if the initial process didn't resolve the issue. A blue screen of death, or BSOD, typically displays a stop code indicating the error type, and sometimes identifying the specific faulting driver. Newer Windows versions may also provide a QR code or support link. Always note the error text, as it is critical for your follow-up troubleshooting. This lesson provides a comprehensive overview of essential troubleshooting areas, including the boot process, recovery tools, system restore, driver management, and techniques for handling various system and application faults. To summarize the boot process, it starts with power, moves to the post test, identifies the boot device, and loads the OS. Legacy BIOS reads the MBR, while UEFI utilizes a GPT-based approach after the initial post sequence. For boot recovery, you can access the Advanced Boot Options menu in several ways, depending on your system, such as using the F8 key or the Shift Restart combination. These options lead you to the Windows recovery environment, which provides critical repair tools like Startup Repair and command line utilities. This view shows the actual Windows recovery environment interface, illustrating the various troubleshooting tiles and startup settings you can modify if your system fails to boot properly. System Restore is a vital tool that rolls back system files and settings to a previous stable state without touching your personal data. Remember to enable system protection and regularly create manual restore points before making major system changes. Here you can see the System Properties and System Protection interfaces, which give you granular control over how space is allocated for restore points and how protection is configured on your drives. Updates and drivers can sometimes cause instability. If a Windows update causes problems, you can uninstall it manually via the Update History menu. If a driver update causes a crash, use Device Manager to roll back to the previously installed version. For severe issues, you might need to use a recovery image or the Reset This PC feature. A recovery image provides a full backup of your system. If you don't have one, the reset function allows you to either keep your files or perform a clean reinstall. To wrap up our discussion on boot issues, always verify your hardware connections and boot priority first. If you face a No Operating System Found error, use the command line tools in the recovery environment to rebuild your boot configuration. For black screen issues, Safe Mode is your best starting point for diagnosis. Moving on to troubleshooting user profiles. A slow Windows boot can be addressed by disabling unnecessary programs in the Task Manager Startup tab. You can also inspect the Event Viewer's Diagnostics performance log for specific delays, or enable verbose boot messages in the registry for more detailed feedback during startup. When users experience delays before signing in, potential causes often involve network logon issues, a corrupted user profile, or problems with GPO processing. A good diagnostic step is testing with a local account, which helps determine if the delay is specific to the domain or network environment. If you suspect a corrupted local profile, you can rebuild it. Log in as an administrator. Rename or delete the old profile folder in the C users directory. Remove the corresponding user entry from the profile list registry key, and log in again to trigger the creation of a fresh, clean profile. Now, let's look at performance troubleshooting. To analyze a system, use tools like Task Manager, Resource Monitor, and Performance Monitor. Your investigation should focus on CPU and memory usage as primary indicators of system strain. Continue your performance investigation by monitoring disk and network activity. Once you have identified the source of the slowdown, make sure to document your findings thoroughly and propose appropriate solutions to resolve the issue. When addressing general performance issues, follow these steps. Identify the cause using Task Manager and Resource Monitor. Take action by ending unresponsive tasks or rebooting, and prevent recurrence by disabling unnecessary startup apps, running malware scans, and keeping drivers and hardware components updated. System faults require targeted actions. For blue screen of death errors, note the stop code, rollback changes, and check hardware. For system instability or frequent shutdowns, inspect the power supply and thermals. For USB or peripheral issues, test different ports or cables and review USB controller drivers. Finally, for application and service faults, recover any data, check logs in Event Viewer, and reinstall if necessary. Ensure services are set to automatic and check their dependencies. In summary, mastering these Windows utilities and troubleshooting steps is vital for any successful IT professional.